today's problem is valid parentheses. We are given a string S containing just the characters, basically three different kinds of brackets, opening and closing brackets. And we have to determine if the input string is valid. Now, the output should be a Boolean here because we will be just returning if the input string is valid. And what does it mean for a string to be valid in this problem? Well, we have three constraints for a string to be valid. It has to fulfill all of them to be valid. The first one is that open brackets must be closed by the same type of brackets. So if we have a simple bracket like this, we have to close it with a enclosing bracket of the same type. Same goes for the different kind of brackets that are given by the problem statement. That's our first constraint. Now the second one, open brackets must be closed in the correct order. So we cannot have something like this because we have to close this bracket with a bracket like this before we can have an enclosing bracket like this. So this, for example, is not valid. This different kind of enclosing bracket. Now the third and the last constraint that the input string has to fulfill to be considered valid is that every closed bracket has a corresponding open bracket of the same type. So we have the same, the brackets come in pairs. We cannot have, for example, 3 opening brackets, but 4 closing brackets. So these all will match, and then we are left basically with only one enclosing bracket, which is not matched with an open bracket. So the string is not valid by the problem statement. Now the constraints is that the string can be from the string's length can be from 1 to 10 to the 4th, and one of the good questions for the interviewer is, do we have to sanitize the string? Are there any other characters besides the 6 characters given by the problem statements inside the string? And we know by the problem statement that the string only contains brackets. So, and also by constraints, the string only possesses parentheses. So we are good on that. Now, for the first example, we have just just simple opening and closing bracket. So we return true. In the second example, we have all 3 types of opening and closing brackets. Each one has its own pair, and they come in order, and there's the same number of closing and opening brackets. So all 3 constraints are fulfilled, and we can return true. And in the third example, we have this type of closing bracket, but this type of open bracket, but this type of closing bracket, so they do not match, so we return false. Now, to solve this problem, the most important thing is to decide which data structure to use. And if you go through the problem, through the constraints that we are given by the problem statement, you will notice that we are only, when we encounter a closing bracket, we are only interested in the last opening bracket that we saw. If that opening bracket is of the same type as the current closing bracket that we encountered, then we are good. They're fulfilling, so far they are fulfilling the statements because, well, they are of the same type. Open brackets have the closing brackets have the opening brackets, so they are in pairs, and also they are in the correct order. We don't have something like this. We have a small parenthesis and larger parentheses. So we are only interested at the last element. So we need a data structure that supports last in, first out kind of approach. We are only interested in what's at the top of the data structure, and you can say also what's at the top of the stack. Because stack in this case is probably one of the best data structure that you can use. Now we will go through one example to see how this works and how the stack behaves in action. So we will traverse the input string given by here. Let me just quickly change the color given here. So we have a set of parentheses, and we will check if the current string is valid. So for each opening bracket, we will put it in our stack, and for each closing bracket, we will check if the last bracket that we put into the stack is of the same type. And if it is, we will just continue traversing. If it's not, we will return false, because by the constraints, we don't have a valid string. So we will start with the first bracket, and it's an opening bracket. So we will place it in our stack, and we don't have any elements, so we will just place it at the top of the stack. Now we will go to the second bracket, which is again the same type of the opening bracket. The third bracket is the large one, so we will put it at the top of the stack, and we will continue to our fourth letter, which is a closing bracket. So the thing that we have to do is peek on top of the on top of our stack and see if it's the same type as our current parentheses. And as you can see, our element at the top of our stack is an opening bracket of the same type as we have here for our closing bracket. So we just remove it from the top, and we continue on traversing the string. Now we are here at our closing bracket, and we see that we have two closing brackets. So we will have the same behavior. We will check what's on the top of the stack, and we see that that we have a match, so we can continue. Now this becomes our top of the stack, so we check it with this closing bracket, and we also see that it fits, so it's a valid pair. So we just remove the element that's currently at the top of our stack and proceed to the next layer. Now we have this type of opening bracket. So we put it, the stack is empty, we put it at the top of our stack, and we traverse to the next element. Next element is this. We check if the top of our stack is forming a valid parentheses pair with our current letter, and we can see that they are of the same type of brackets. So we can just traverse to the end of our input string, which basically means that that our string is valid. The only thing that we have to check is if our stack is empty. In this case, it's empty. This is the last element that we popped when we were comparing it with this. And we know that it's empty, so the string is valid. Why do we have to check if it's empty? Because we have to have the same number of closing parentheses as we have for the opening bracket. So for example, if we have this case, we would have, first we would put two brackets here for this because they are opening. We would match them with this and this. And then we would have this. So we would have this case. In this case, like we would have a we will have a match for this closing bracket. But for example, if we have it another way around, if we have three opening brackets but only two closing, in that case we will have three elements that are in our stack. We will only remove two because of the two closing brackets, and the stack will not be empty at the end of the traversal, which basically means that we don't have a valid pair for our first parentheses, which means that the string is not valid. And because we are traversing the whole string, that leads us to a linear time complexity proportional to the length of the string. And also because we can, by the problem state, we can have all opening brackets in the whole string, which will not be valid, but our algorithm will put every single bracket inside the stack, which basically means that we will have linear space complexity as well, because we can place all the elements in the input string to our stack helper data structure. Solve the problem using Java programming language. First, we will declare our stack data structure that we will use to store our opening brackets. Next, for the code readability, we will create a bracket mapping hash map, which basically maps our closing bracket to the corresponding pair the right pair of opening brackets. Next, we will traverse through the whole string, and each time for the letter, checking if the current letter is a opening, well, current symbol is an opening bracket, and if it is, we will push it to our stack. If it doesn't, that means that we encounter the closing bracket. So we first check if the stack is empty. If the stack is empty, that means that we don't have a valid pair. We don't have a pair for our current closing bracket. So we will just return false in that case. Otherwise, if the stack is not empty, we will check what we have on the top of the stack. And if we have a valid opening bracket, we just pop it and continue our traversal. And to see if it's a valid opening bracket, we will use our bracket mapping. So to get the corresponding valid opening bracket. And if we traverse our whole string without running out of opening and closing bracket pairs, so we have all matches, we will just check if the stack is empty. That's our scenario where we have more opening brackets than we have closing brackets. If the stack is not empty, that basically means that we didn't match all the opening brackets. If however it's empty, we know that we have all the pairs valid, so the string itself is valid. And in that case, we will just return true because the stack will be empty.